Huh? Langs van by Juffrou Conradi. Okay. Right. Okay, just for those at home, I'm quickly going to skip through. You guys can pause and play. If you still need to copy something, there's A and C. Number C6 and then E and the start of F. The rest of F. G1 and 3. And then 5, 7. Please look at all the steps. And then number 9, please let me know if there's any questions and I will let you know directly. Don't ask on the group. Okay, right. So now we are busy with like terms. That's on page 37 in your textbook. Now, what are like terms? Yeah? Yeah? Okay, but when we call those letters, we call it? Not integers? Yes, but what must be the same?
Variables.
The variables or the unknowns. Yes. Okay, so, oopsie. So at like terms, the variables are the same. Okay, now, only like terms we are allowed to add and subtract. So those ones that look exactly the same, they are going to be like terms. Okay, so just an example, x squared y. Will that be the same as, I can't make an equal sign there, sorry. Will that be the same as x y squared? Because the first one has got x squared, but the second one has got just x. So they are not like terms. Okay, if I were to do this, x squared, y squared, and over here, x squared, y squared. Now they look exactly the same, right? Okay, so the variables or the unknowns must be exactly the same. And only when they look exactly the same, then I can add and subtract. Now, remember that if I have this 6x squared y squared minus 4 x squared y squared, because the coefficient is now the number in front of those unknowns. So the 6 and the 4, they aren't the same. Are they still like terms? Yes. Okay, so it's not the coefficient that we have to look at, it's the variables, the unknowns. Okay, now we said if they are like terms, I am allowed to go and add and subtract. So over here, 6x squared y squared minus 4x squared y squared is going to give me how much? 2. And then remember, the variable stays the same. So it's going to stay x squared y squared. It's like saying 6 bananas minus 4 bananas. It will now be 2 still bananas. No? I know it's a very stupid example, but just to explain to you guys that I can't now let those variables disappear or change, because then it's not the same thing anymore. Okay, so any questions there? Right, now, when does it actually change? It only changes, the variables, no? When do the variables change? It only changes when we multiply and divide. Okay? Let's use an example. I'll talk about the wording there now. So an example will be 6, right? 6xy times 2 x squared y. Okay, now, because we are multiplying, the variable is going to change. So, what I usually do, let's make this a minus. How I tick my boxes is I remember first multiply the signs, then multiply the numbers, and then multiply the variables or the unknowns. Okay, so let's start with the signs. A negative times, what's written here? A positive. Will give me a negative. Okay, 6 times 2 is going to give me 12. Yeah, times, eh? Okay, now x times x squared is going to become x to the power of when we multiply, base is the same. What do we do with exponents? We add them. So that's going to become to the power of 3. Because even though there was no exponent written here, it's actually to the power of 1 and to the power of 1. Do you remember that from last year? Yes. Okay. Now that's only the x values. Now let's look at the y. Y to the power of 1 times y also to the power of 1 will give me y to the power of 2. Okay, you guys fine with that? So remember, your variable is only going to change when we multiply or divide. Just for interest's sake, over here we multiply. What do we do with our exponents when we divide? We subtract. No, we minus. Okay, but we'll do examples just now. Right. Now, let's look at fractions. Now, if a fraction is written like this, x over 4. That's a fraction, eh? But what I'm actually also saying, that's the same as x divided by 4. No, so I can write it in the form of a fraction, or I can write it like this. Do you guys all understand? Okay. Now, whenever we have fractions, we can cancel out to simplify it. But before we can cancel out, you'll see that I wrote it here. Must have one term at the top and one term at, and you can't see the rest, bottom. Okay. Remember, you can't cancel out if you have more than one term at the top or more than one term at the bottom. All right. We'll do examples just now. Yeah.
Can you cancel if you have a term and a variable at the top and a term and a variable at the
Yes,
bottom?
yeah, but we'll do an example just now. Okay, now we spoke about terms now. We said one term. How do you know, or how do we distinguish between terms? When does it cut off? When we see it? This is now revision work from last year. A new term starts as soon as you see it. Come on, but how do you know it's a new term starting? There's a plus or a minus, so it cuts off when there's a plus or a minus. Do you guys remember that? Huh? Not.
Common knowledge, actually.
Okay, so look, just an example. This will be term 1. No? Then there's a minus, so it means, okay, stop, new term starts. So that will be term 2. Do you guys now understand what I mean? Okay, good. Right, so that's cancelling out. But how are we allowed to cancel out? Over here, I said only up and down and across. Hey, you guys fine with that? Okay, so let's do an example or two. I'll come back to the slides a little later. Number 1. 2x minus 3x. Okay, so what's going to happen here is, can you see I've got two signs next to each other? So that's going to become 2x plus 3x. Okay, now I see that I have to add, but before I add, I must double check. Are they like terms? Yes, because they have the same unknown. They both have x's, so I am allowed to add. Now 2x plus 3x will give me
5x.
5, and it stays x. Good. Easy now? Good. Let's look at the next example. Over here, I've got 2 signs and 2 signs. Okay, so that will become minus times a minus is going to become a positive. Do I have to write positive? Not here, because there's nothing in front of it. So we assume that it's a positive 7x. Okay. Then a positive times a negative is going to give me negative 9x. Okay. Are they like terms? Yes. So I am allowed to subtract. And 7x minus 9x is going to give me minus 2x. Good. Yeah. Wait, come again? Yes. Let's say it was 7x minus 9y. Then that would be where you stop. You couldn't go any further. Yes. Okay. Can I skip? Oh, yeah. I'm going to come back so you guys can copy. It's just for the recording to keep it short and sweet, no? Okay. So, over here. Minus 3xy times minus 2xy to the power of 2. Do we need to look at like terms? We multiply. No? So we don't have to worry about like terms. What we do know is because we're multiplying, what's going to change? My variables. No? Okay, right. So, negative, and when we multiply, I said we look at the sign, and then the numbers, and then the unknowns. No? Okay, so let's do the signs. A negative times a negative is going to give me a positive. But do I have to write that? So I can leave that out. Good. Then the numbers. 3 times 2 is going to give me 6. X times x is x to the power of 2. And y times y squared is going to give me, right, y to the power of 3. Good. Are you guys okay with that? Good. Let's look at the fraction. Okay. Now, we said whenever we have fractions, before we can cancel out, make sure you have one term at the top. Do you see any pluses or minuses at the top? So there is just one term, no? And at the bottom, how many terms have I got? Just one term. So that means that I am allowed to cancel out. Okay, so let's do that. 7 will go into itself once. 7 will go into 14 twice. Okay, now, can you see at the top I've got a squared, and at the bottom I just have a. Now, which one can I take? You can only take? I can't take a squared because at the top, yes, I could take a squared. Can I take a squared at the bottom? No, I've got too little. So whenever you have something like this, you always take the one with the lowest exponent. Okay, so that means I can only take a. So if I take a at the bottom, it means I can only take one of those a's at the top. Now there was 2. If I take one, it's going to become 1. I don't have to write that one. Okay, can you see that I don't scratch out the a itself? Otherwise you get confused. So watch out for that. Okay, let's look at the b's. I've got b, and then at the bottom, b squared. What can I take? Only b. Okay, so b at the top, which means that I can take only a b at the bottom. So that's going to become 1. Okay, now let's rewrite what we have left. It looks very bad. So at the top, 2 a, and if you want, you can say to the power of 1, but it's not necessary. Okay? At the bottom, minus 1b, and again to the power of 1. But you don't have to write the to the power of 1. Okay? Even if you wanted to write it like 2a over minus b instead of minus 1b, it would still be correct. Okay, so you can write that one or you can leave it out. It doesn't matter. But it's only when it's a 1 that we can do that, right? Okay, good. I'll come back for those that are still copying. I just quickly want to finish the slides. Right, let's look at this one. Minus 3m squared n. And then what's written here? When something is written in front of a bracket, it means we've got to multiply that with everything inside the bracket. No, you guys get that? Was I able to simplify inside the bracket? No. Okay, so in grade 8, I think you guys did this. I've got to multiply this with everything inside the bracket. So I'm going to multiply it with that one. Do you remember that? Yes. And I've got to multiply it with this one. And I've got to multiply it with that one. Do you remember that? Okay, right. So minus 3m squared n times minus 2m. Minus times a minus is going to give me a positive, which I don't have to write. 3 times 2, 6. And then m to the power of 3n. That was this multiplied with the first term. Yeah. Leave the m. Yeah. See over here, we're not finished yet, no? We only multiplied it with that first term, so hold on. Okay, these two, or minus 3 times minus 2 gave me positive 6. And then m squared times m became m to the power 3. And then that n didn't have another n, so it stays just n. Good. Now we've got to multiply that with a 3n. Okay? Now minus 3 times positive 3 is going to give me minus 9 m squared n squared. Okay? And then the last one, minus 3m squared n times the minus 5 is going to give me positive 15m squared n. Everyone okay with that? Yes, ma'am. Good. Yo, lots of slides. Okay, I'm going to skip. Oh my goodness. Okay, I will do a short video on this one and then you guys have homework. All right. Yes.